The exosomes are or specific segments, specific portions of cells, and so it's sort of one step, I would say, more pure than just taking stem cells and breaking them apart. I mean, you can expose stem cells to vibration, rupture them. There's actually more benefit that comes from that.
Welcome to Peak Human Labs, where I share amazing interviews with incredible human beings who are leaders in how to optimize your health and get you to peak mental, physical, and mental state. My name is Dr. Sanjeev Goyal. I'm a physician for the past 20 years, specializing in longevity, precision medicine, and biohacking. And my mission is to alleviate the suffering we all face and will encounter when dealing with illness, sadness, and loss. And to this end, I'm sharing these conversations with people who can shed light on how to live more purposefully and intentionally so that you can be inspired and create your own path to wellness and fulfillment. Hi, everyone. Today, we're going to be speaking with Dr. Cory Goldberg. Dr. Goldberg is a renowned plastic surgeon who's also an expert in longevity. And today, he'll be talking all about the impact of antioxidants and our health. We'll be also learning about exosomes, and we'll be learning about how important the skin is as a barometer of our health. I hope you enjoyed today's episode, and we'll see you on the other side. Hi, Cory. How are you?
Good, thanks, Sanjeev. How are you doing?
Good. Thank you so much for joining me. I'm really excited to learn more about your journey on longevity. Take our viewers, listeners on a little bit of an understanding. I mean, you're a plastic surgeon, and I understand you've done a lot of work in longevity, and I'd love to, if you can kind of give us some background. Yeah, that'd be great.
Yeah, for sure. I get asked the question. Most people think of a plastic surgeon as the beauty surgeon, and you don't really think about the background of that. So, my undergrad was physiology, so how humans function. And while I was doing my plastic surgery residency, I actually spent a couple of years doing research, and I got a master's of applied science and biomed engineering focused on stem cells. So, I spent a couple of years doing stem cell research, and then when I entered practice, within the first few years, I started looking into ways of managing surgical care and post-op pain. And, I came across some tools that then led me to do research on reactive oxygen species and oxidative stress. And that's kind of, translated over the years into me getting more and more involved in the health of my patients, and actually trying to, benefit people as a whole using these kind of health tools. My practice, I've now really kind of transitioned to that junction between the beauty and health, which, I think are so closely related.
Oh, wow. That's so interesting. Basically, that is exactly what people are talking about now is stem cells and reactive oxygen species and things like that. You've been doing this for quite a while then. You've been really at the forefront of that understanding.
I'm really fortunate. I spent a couple of years in the lab. I hate to say how long ago that was. That was more than 20 years ago. It was 2001 to 2003. I was in the lab, but the lab I was at the University of Toronto at the Institute of Biomaterials and Biomed Engineering. I was really lucky to be under the auspices of who I think is still to this day one of the leading researchers in mesenchymal stem cells globally. So I was actually in the lab for some really amazing technology developments and isolating stem cells from umbilical cord Wharton's jelly and things like that. So I was, I guess, in the right place at the right time, and I had the right people kind of mentor me towards this kind of holistic view of patients.
Let's just jump right into that because let's start talking about exosomes and stem cells and things like that because we have talked to some other guests in the past, and I think your insight will just be very interesting. What's your thinking? Where are we at with this technology? How successful is it, and where are you using it? What's the promise of this?
It's a great question. And I don't know that there's a firm answer. But one thing I'll tell you is, when stem cells were first considered, 20 or more years ago, it was looked at as a building block. You start with a stem cell and you grow organs, or, there were, scientists that were able to grow cartilage and manufacture it in the shape of an ear. And, everyone thought we would be growing organs in no time. And really, it doesn't work like that. The fundamental benefits, I think, of stem cells, and, I guess remembering that stem cells is such a broad category. I mean, there's so many different types, but in general, I think stem cells have two main functions. They're anti-inflammatory and they are growth stimulators. And if you can leverage those two properties of stem cells, then you can treat tons of different diseases and benefit people in lots of different ways. And so I think that fundamentally we need to be applying stem cells for those purposes. The way it's being used now, in a general term, it's not very effective, if I can say that. I mean, lots of people are getting stem cells injected into them, and it's doing very little.
Let's unpack that a little further. So normally we're talking about mesenchymal stem cells, right? And one can either inject their own stem cells or they can inject from a donor like umbilical cord blood stem cells or so on and so forth, or potentially adipose tissue derived or even bone marrow. You said something there interesting. You said about this, it's anti-inflammatory and growth promoting at the same time. Potentially that's contradictory because sometimes we think that growth actually causes more inflammation. In an ideal world, why stem cells do those things?
The function of the stem cell ultimately is to become different things. So, in an area where there are stem cells, they need to first off have a healthy environment to work in, and so there are lots of anti-inflammatory mediators that stem cells produce to sort of create a healthy environment to grow in, and then they need to grow and make more of themselves. As an embryo, whether you're growing something into muscle or you're growing something into bone, you need to grow a lot of it. So there are growth factors and stimulants that actually help cells to grow. And if a cell, one of those mesenchymal stem cells, is going down the path of becoming bone, it actually will secrete things that help other cells around it also become bone. So it's kind of almost a self-propagating pathway. That's very much on an embryonic level when you're trying to grow tissue. Taking a step back, looking at as adults, what we could benefit from that is the anti-inflammatory and pro-growth. And the comparison I would make is, PRP, platelet-rich plasma. I mean, you're very familiar with that. Listeners, I'm sure, have heard of PRP. PRP is an amazing tool. And platelets, of course, those are the carriers in our blood of all of those mediators, the growth factors, the anti-inflammatory mediators. When you get an injury somewhere in your body, that's how it gets there. I mean, the platelets go and aggregate and let that stuff out. Stem cells are, in a way, they're the same thing, except they are active cells. They keep reproducing. They have, the engine to create more protein. So a stem cell does the same as a platelet does, except it's not just a static collection as a platelet is, which, platelets, of course, they have no nucleus. They can't make more stuff. So platelets are really limited. I mean, they do very good things, but when you put them somewhere, they let out that little burst, that little ignition, and then they stop. Where a stem cell can function on an ongoing basis, and so that can produce tons and tons of anti-inflammatories and growth factors on an ongoing. The potential benefit of that is like PRP, but amped up, so that it, for weeks or even months, could continue to have that benefit.
If you inject stem cells again in an ideal world, how long do those stem cells stick around for? You're saying that, I mean, this lasts for potentially months. Is that actual cell living there and reproducing?
So it very much depends on how it's put in. So there have been animal studies that have looked at subcutaneous injections or intramuscular injections, and those stem cells actually do stick around for months, and they keep producing good things, anti-inflammatories. They can be used to transvect all kinds of different benefits to the host. That can be done on a therapeutic basis. Of course, that's not approved for humans, and so I don't advise doing that. That is something that there is evidence showing that in animals. Now, the way that most people are getting stem cell treatments done, and again, this is not being done in North America, as you know, Canada and the United States. This is not Health Canada approved. This is not FDA approved. You can't put cells into other people. But offshore, that's a different story. People are getting stem cells put in, and it's fascinating because the answer to your question, how long do they last for, is on the order of minutes.
That's what I thought.
They don't. The stem cells are huge. They're big compared to little capillary blood vessels. And so when you take stem cells and put it into someone's vein, the first thing that it does is it goes back to their heart. And then from their heart, it goes into their lungs. In their lungs, it stops. It stays there. The stem cells actually don't make it out of the lungs. And 98% in first pass end up stuck in the lungs. And they actually do break down, and the white blood cells will engulf them and eat up all the good parts of the stem cell. And actually, that does have anti-inflammatory effects, and some of that does make it to other parts of the body. So, in fact, some of the stem cells actually have a benefit when they're injected that way. But generally speaking, it's not nearly as much as what people are expecting because of that first pass effect and the fact that the stem cells actually never make it anywhere else in the body.
Well, that's very interesting. But you're saying that if you had, let's say, potentially subcutaneously injected it or not putting it intravenously, it could stick around longer. Like if you put it into a joint, let's say, for example.
That's true. Whether a stem cell could exist in the fluid of a joint, that is uncertain, because, of course, that's a very oxygen poor environment. So I don't know that anyone has done that, but in theory, it could. And if it survived and was able to be in that environment and still be nourished, then yes, it would continue to survive and it would continue to produce all those good things. Now, it's an interesting corollary to that. If you take stem cells and you irradiate them, so actually you kill them, and then you inject them intravenously, the exact same thing happens. They make it to the lungs and they get engulfed and broken down, but you get the exact same benefit. The idea that you have to have these live, healthy cells and that's going to give someone, it actually is not true. So you can irradiate them and kill them and have the exact same benefit. And even further, you can irradiate them, kill them, break them up, actually mulch them, inject them, and have the exact same benefit as well.
And let's just jump right into that. So my understanding that's called exosomes, or that's the little nanoparticles that exist within stem cells, and that's legal for at least topical administration in Canada. But I think the evidence looks pretty good on the use of exosomes.
I agree. The exosomes are or specific segments, specific portions of cells, and so it's sort of one step, I would say, more pure than just taking stem cells and breaking them apart. I mean, you can expose stem cells to vibration, rupture them. There's actually more benefit that comes from that. It would be very difficult to market or get any kind of regulatory approval for that because it would be a very mixed bag. You'd sort of be throwing the kitchen sink at everybody. So exosomes are a very coned down version of that. It's specific segments of cells purified, and that way at least you can register claims and say this is what it does and this is the thing that I'm injecting. So the exosomes are a coned down and realistically applicable way of using stem cell products. And I agree, absolutely, lots of evidence to support their use. I would say it may be one of those things where the pendulum has swung a little far. People's expectations of exosomes are a little bit more than potentially they can accomplish. But I do think it's an area that's very promising, and there's definitely lots of clinical benefit from that.
Is there any concerns you have about injecting somebody else's exosomes into your own body? Like, do you think there's risks? I've heard, I did interview with Drew from Acorn, and he was telling me that he had major concerns about exosomes being taken in from another body. There'd be risk of reactions and things like that.
Yeah, Drew's a smart guy. He knows the score, and I'm very familiar with Acorn. That is an excellent technology for harvesting and holding onto your stem cells. Absolutely true. Unfortunately, we have to face the issue that any tissue, whether it's a fragment of a cell or a whole organ coming from somebody else, anytime you take something from one human and put it in another, or if it's from an animal, anytime you take something from an animal and put it in a human, it doesn't matter if it's an entire organ or an exosome, some fragment of a specific cell, there's a risk of transmitting infectious disease there. I mean, bovine spongiform, mad cow, no one saw that coming. And suddenly it became very apparent that proteins can transmit diseases. It's really important when you're considering transplanting things between individuals that account for that potential risk.
Yeah. And so, for people who are listening and they're in North America, what should they be, looking at if they want to potentially use exosomes for treatment?
So at this point in time, the only exosomes that I'm aware of that are approved even for topical uses are plant derived. There's a company I'm aware of that produces exosomes from rose cells. In the end, an exosome has substances in it, and those substances don't vary that much between animals and plants. A lot of our biochemistry evolved from 3.5 billion years ago, from the time that life first started on this planet. And people often distinguish and say we're so very special, we're totally different from all these animals and all these plants. The reality is most of our biochemistry is the same biochemistry you'd find in a tomato. And so actually taking stuff from plants has potential benefits, but like anything else, the proof is in the data. You need to know what you're getting in those exosomes, and there needs to be some evidence that it's doing something. You can't just say something's an exosome and assume it's going to work. But certainly using plant-derived exosomes is a way of stepping around the whole infectious disease concern.
And it could have similar benefits because you're saying these growth factors are similar in plants compared to animals. I think you have some interest. I saw you did some presentations on senescent cells, or like, just tell me more about that. Or you did mention you had that whole piece on reactive oxygen species, but maybe just take me through that piece.
Let's talk about the senescent cells and then talk about the reactive oxygen species, because the senescent cell story, I think, is fascinating when it comes to skin. I'm a plastic surgeon with a holistic view. I look at the whole body, but, obviously I have a bit of a focus on the skin, and for good reason. And as you well know, it's the largest organ in the body by weight, and it carries out so many different functions. So, one of the things about skin that's really fascinating is it contains these senescent cells. And, for those listening, watching, senescent cells are cells that are damaged and they stop replicating. So they don't copy themselves, they don't duplicate anymore, but they're not cancerous. They're just harmed. They're unhealthy. So they don't duplicate, but they release all these terrible substances that harm the cells around them. And they secrete stuff that can make it into the blood and harm other organs also. A lot of people, as you probably know, they call these things zombie cells, because as they get in contact with other things, they're highly harmful and, convert other normal healthy cells to become zombie cells. So, these senescent cells, they're in all of our organs. It's one of the important hallmarks of aging. But in the skin in particular, a couple of things about it that really struck me. First off, the presence of senescent cells is directly related to sun exposure. So, senescent cells and all the markers of aging of the skin, it's, a time thing. As time passes, those things accumulate. The sun and sun exposure does the same thing, but it accelerates it in exactly the same way. So 1 hour in the sun is actually enough to measurably increase the number of senescent cells in your skin.
Is that permanent? Like, is that a permanent change or transient?
It's potentially reversible, but it depends on your long-term behaviors. I mean, there are definitely things that you can do and eat, behaviors. There are supplements and things that you can take that are specifically senolytics, that specifically reduce the load of senescent cells. So it's not necessarily permanent, if you're doing those right behaviors or taking those supplements. If you're not, and you're just, every day exposing yourself to more, then no, it's absolutely permanent, and it would increase over time until such point as you have age changes and you can see the wrinkles and the sun damage and the discoloration, and then you start getting skin cancers. That's sort of the next step past that. But those senescent cells are, that's the source of aging. That's why our skin thins. That's why it ends up looking so papery. Here's the thing that really struck me. The fact that the senescent cells in your skin have such a high impact on the rest of your body, that means that these cells, these zombie cells in your skin that you can increase with sun exposure and poor health, that actually ages your organs measurably.
That's the first time. Yeah, I never thought of it like that. That's another reason to take care of your skin, because it's impacting the rest of your body.
100%. And so, most people acknowledge the idea that beauty is a reflection of your health, right? I mean, if someone is a healthy person, their skin looks good, they're glowing, like, you can see when someone's healthy by their skin. But it goes in the reverse also. This is bidirectional.
Yeah, beauty's not just skin deep. What you're saying, it does matter. Like sometimes we think, okay, just your skin, it's your skin, but it is, yeah, right, reflection of deeper.
Beauty is health. Beauty is health. They are one and the same, Sanjeev. And it amazes me that people take such little care of their skin, and it is fueling their age process. It is actually making them older. So, telling someone that they should put on sunscreen and be careful in the sun, yeah, so you don't get skin cancer. But by the way, also it's so that you don't get heart disease and kidney failure and all those other things too.
Well, I mean, I'm darker skin, but I've told my kids a little bit like, don't worry so much about the sunscreen, because I'm feeling like they're becoming like a little paranoid, but because they're about the vitamin, because we have low vitamin D here too. So I guess this must be a somewhat of a balance, I expect. What's your thinking on that? Like, this, if you're taking sunscreen, are you like, you are blocking some of your UVB rays, right?
It's true, and I can't say that I'm the gospel on this, and so there are other opinions out there, and I'm prepared to acknowledge that. But I'll share my thoughts. You can get vitamin D in a bottle. It's readily available. It's cheap. It has no side effects, and I have yet to have someone tell me what the downside of taking vitamin D is. So if you can shortcut, if you can biohack that part of your biochemistry, and you don't need UV exposure to produce vitamin D, and you can have it anyways, I don't see a reason to not do that. So, that my approach is, minimize sun completely if you can, and take the vitamin D that you need to augment that. And that doesn't mean not going outside. Look, I'm not a shut-in. I like sports outdoors, but it means being responsible. And it would be impossible to block all the UV radiation, but most certainly it is possible to block most of it and avoid a lot of it. And if you behave well, that will last you in the long term. So it's interesting because I know the next thing we're going to talk about, I'd like to get to that reactive oxygen species. This actually is a perfect segue: UV damage and its relation to that. A lot of people think about UV and they recognize that it's harmful to you. But most people don't think about how. You sort of think about this radiation, this UV radiation, and how it impacts your cells. And you kind of picture these electric waves or radiation waves going through your cells and hitting your DNA or causing harm. And actually, less than 10% of the damage to your cell and your DNA is directly from the ultraviolet radiation. So, mass, molecules, most of it is space, right? I mean, there's very huge distances between the actual atoms that make up our molecules, that make up our body. So when, UV radiation wave particle, when that passes through you, it actually doesn't hit very much. But what it does do, it leaves behind a trail of oxygen-free radicals. And as it zips through, it energizes and causes a bunch of those oxygen molecules to become harmful oxygen-free radicals. That's causing oxidative stress. And it's in fact the secondary effect of the oxygen species on your proteins and your DNA and your cell. That's where most of the harm from UV is coming. It's not directly from the UV itself.
So the UV rays, this UVB, hits the oxygen O2 molecule, and you're saying adds like a electron or something. What does it actually do?
Yep, it's converting it to an oxygen-free radical. Superoxide anion, the O2 minus is kind of the most common of those. Common term for this is reactive oxygen species, the ROS, right? So the reactive oxygen species is any oxygen molecule that's unstable. If it's in a standard O2 double bond between them, that's very stable.
Mm-hmm.
But if you add or take away any energy from that, it immediately becomes unstable, and that is a huge driver of aging. Many would consider it actually one of the primary drivers of aging and a principal source of inflammation, and that process of a gradual decline in your epigenetics and your genetics and your proteomics. All of those things are affected by reactive oxygen species.
Oh, wow. Okay, I didn't think of it like that. That's very interesting. I mean, there seems to be many of these antioxidants then, right? Like people are taking antioxidants. First of all, before we jump into supplements, but what about like topical antioxidants? Do they work?
Mostly not. Mostly not. It's not that it's completely ineffective. The biggest issue with vitamin C is that once it's exposed to air, it oxidizes. So it itself reacts. The vitamin C sort of delivery methods that I've seen that are even somewhat effective, they have a special delivery jar where it's actually sealed inside. There's no oxygen, and it's individual pump to get material out, but the stuff that's inside is still preserved. I've seen others that come in a tub or open tube. That's totally useless. The second that that's exposed to the air, it's completely reduced. It's totally ineffective. Once you pump it out though, and you put it on your skin, some of it would absorb and have some clinical efficacy. But again, stuff that's on the surface would oxidize quite quickly. So the clinical benefit is limited of vitamin C. Topical antioxidants, I don't know any that I would hang my hat on and say, yeah, that's the go-to. That's how you manage oxygen-free radicals.
And just before we jump on to just to talk a bit further about antioxidants, can you send us some like sunscreens that you recommend?
I'll tell you now, honestly, I'm very brand agnostic when it comes to sunscreen. There are two things that I think are important. One is tolerance, and two is that it's mineral based. So, tolerance really comes to what are you going to use? I could tell people to use any number of different sunscreens, and if they don't use it, it's not going to do a thing for them. My advice to people is try different ones and find the ones that you are comfortable with, that it's light enough or easy to apply, something that's cheap and readily available. So, patient compliance in this instance is, I think, the most important part. That's going to lead to actual usage. And then the second, ideally, you're going to want to look for mineral-based sunscreens because those are the ones that are, mechanically blocking the incoming ultraviolet radiation. Titanium oxide, that reduces physically the actual entry of UV. There are chemical ones, and there's enough evidence around those to say that there's some potential future consequence of that. I'm not going to come in firmly on that because I think that you achieve more benefit protecting yourself from the sun, even in the event that you're using a chemical, type of sunscreen. Because I think that the effects of the sun are way worse than whatever is going to happen from the chemical sunscreen you're using. That's just my personal.
But titanium oxides are very, very readily available. These are not like hard to get.
Nope. No, you're right. You're absolutely right. That is very readily available.
Yeah. Okay. Let's move on. So then tell us about, so how can we get these antioxidants then if it's not by topical?
Mentioned earlier the idea of a dietary source of antioxidants, and that's very common. Lots of people talk about eating antioxidants. Get your blueberries, your goji berries. There's lots of foods that have antioxidants, and carrots have beta carotene. That's a great antioxidant. That's why they last so long in the fridge. So there are definitely dietary sources of antioxidants, but they all suffer from one limitation, and the limitation they suffer from is that it is a direct chemical antioxidant effect. And what I mean by that is, when you eat your blueberry, it's got molecules in it that are antioxidants. And each one of those molecules has the ability to neutralize one oxygen-free radical. So, when you eat that blueberry, you're going to absorb that antioxidant molecule, and somewhere in your body, there's an oxygen-free radical. It's going to, combine with that molecule from the blueberry. It's going to cancel each other out, and you've just saved yourself one oxygen-free radical, and that's amazing. The clinical benefit of that, what you actually get out of it, is very limited. And you can imagine why. I mean, how much blueberries would you need to eat in a day to get enough of those antioxidants in you to actually make a difference? And the answer to that is astronomically high. It's impossible. And so because it works on that direct one-to-one mechanism, it's very limited. One of the most important enzymes that we have in our body is something called superoxide dismutase. So this SOD superoxide, you got it, SOD superoxide dismutase. So this SOD molecule, again, looking back at our biochemistry from a few billion years ago, this stuff evolved around 2.5 billion years ago. So life has been around 3.5 billion years. 2.5 billion years ago, something happened in our atmosphere, and that is we started to have oxygen. Before that, there was not really very much oxygen, and it's because we didn't have any plants. So when plants evolved and photosynthesis evolved, suddenly oxygen started to accumulate in the atmosphere, and it actually almost completely ended life on the planet. It was called the Great Oxidation Event. It was almost an extinction level event. And the molecule that we evolved, that our ancient ancestors, 2.5 billion years ago evolved, it's this enzyme, superoxide dismutase, SOD. And this stuff is produced by every life form on the planet, every plant, every animal, every single celled organism, eukaryotes, prokaryotes, every single one, even our mitochondria produce their own form of SOD. This is the fundamental enzyme of life. I can't think of a more important enzyme in our body. And so this enzyme we have a fixed level of it in our body. And every single cell in our body produces this stuff because we need it. And it works enzymatically, right? It's an enzyme. So that means it's catalytic. So it's used over and over and over again. So it will reduce a superoxide anion. And then that's further reduced by two other enzymes called catalase and glutathione peroxidase. And that eventually becomes water and oxygen. So that's sort of how we excrete that stuff. But superoxide dismutase is kind of the king. That's the first step in the reaction. And it will reduce 1 million oxygen-free radicals before it's damaged enough that it needs to be recycled and reused. So it's 1 million times more effective than that blueberry molecule, for example. And so this is why most studies looking at dietary sources of antioxidants just hasn't shown very much benefit.
Yeah, if anything, there's been no real mortality and benefit from all these beta carotene supplement studies and all that, right? What you're saying is that it's not enough, like the amount is so little.
It's so little, and the mechanism that it's working on, how can you expect all the molecules from your blueberry to really make it to all the spots in your body before it's already been used up? I mean, there's oxidative stress in your intestine. It probably doesn't make it much past that. In the end, even though these things are important and having that as a part of your diet is important, and I fully support eating antioxidant foods and a broad range of plants, in the end, it's not effective for what we're hoping to achieve. It's not going to achieve it. And so really what we need is more of this enzyme, this SOD thing. And there's no reason that we would have ever evolved more of it, right? Because up until, 50,000 or 100,000 years ago, we lived to 24. I mean, it's only been in the past 100,000 years that our life expectancy has gone past that. And at that point, then our oxidative stress starts catching up with us and causing aging and diseases and cancer. If we lived till 24 and then died, we would not really see the effects of this oxidative stress and reactive oxygen species. So there was never a natural need for us to evolve more of it. And so that's why taking exogenous, taking extra of this SOD molecule is so potentially beneficial. And actually, there is a source that you can take orally that actually gives you more of this SOD. I'm a huge fan of that nutraceutical. I think it has immense health benefits.
Okay. Yeah. So tell me, so that supplement actual SOD itself?
Yes, yeah, it is. So it's a biopolymer. So it's actually a combination of two molecules. One of them is SOD, and it's derived from a melon that's grown in France. And this melon just happens to have really high concentrations of SOD in it. So it's easy to purify. But, as we talked about earlier, plant biochemistry in ours is really no different. That SOD molecule, the enzyme is the same. It doesn't matter that it's coming from a plant. So the SOD is purified from this melon, and then it's protected. So if you just eat a protein of any kind, SOD or anything else, you eat it, you digest it, right? You eat meat, you eat anything that has protein, your stomach acid breaks it down into pieces, whether it's amino acids or peptides. So you can't just eat SOD and expect to absorb it. It would never work. So what's unique about this stuff is that it's SOD and it's encapsulated on a molecular level with gliadin. And gliadin is a component of gluten. So it's actually really tough. It helps to protect the SOD from stomach digestion. It delivers it to the walls of the small intestine, and where it gets absorbed and the SOD is liberated and then circulates. So this nutraceutical, this stuff actually, you take this biopolymer, you absorb the complex of the gliadin SOD molecule. SOD is then released, and it actually goes into the blood, it goes to the organs, and this has been measured, and it is a significant increase.
Is there any way to test your SOD levels, like, or that the supplement increases SOD? Is there any way to do that?
Yeah, there is. Although I'll be honest, I don't know any labs that do that, but you can absolutely measure SOD levels in the blood. I've been party to animal studies that have looked at that. And in humans, we've looked at tissue levels in hepatocytes, skin. So it is measurably, increased not just in animals, but in humans, but it's not a routine lab test. Although that would be, I'd really love to find a lab that would do that.
Is there any genetic variation that we have? Like some people produce more SOD than others?
That's a great question. And honestly, I don't know the answer to that. But like anything else in precision medicine, I think you ask a very good question. There would definitely be some people who would produce more than others. And, if I was to take that another step further, I wonder if there would be a correlation between, natural SOD levels and skin and overall aging, all the hallmarks of aging. I wonder how much your endogenous SOD production relates to your aging profile.
What's the name of the supplement? Where can people get it? And we'll put some code so that they can maybe get a discount. We'll put that in the show notes. But if you want to just let people know.
The product is called Glycin, Glisodin, and it's available through Amazon. So you can go on Amazon and find it. Glycodin.org is the website that has all the scientific publications. So the clinicians, scientists who are listening in, if you go to glycodin.org, there is all the papers and publications around that. And I want to clarify, I have no financial relationship with this company. I own none of it. I have no futures. They don't pay me. I promote this stuff because I really believe in it. I've been using it for 14 years. I use it for my patients for surgical recovery. It has made such a huge difference in my life and in the life of my patients. It is a moral responsibility for me to share this information. Yeah, so with my patients, the thing that struck me, when I first started offering it, honestly, I didn't believe it. I didn't think it did a thing. I offered it as a way of appearing to be a holistic surgeon. And the thing that really caught me off guard is that I actually saw a difference. And it was an overnight change. I was probably 3 years into my practice, and I started giving it to my surgery patients. And I suddenly noticed that they were coming back and telling me that they didn't have any pain. They didn't need pain medication. I saw way less swelling. And I thought, wow, 3 years, now my hands, like now I'm actually a good surgeon. I've been practicing enough. I know what I'm doing. And it didn't take me long to realize that the difference was so stark, and it wasn't just me. And that's when I really started to look into this stuff and recognize the mechanism that it was acting on. And since then, there's been a whole slew of new papers. Actually, I've done 3 studies for this product, looking at safety around surgery, looking at skin inflammation markers.
And they improved. They've showed less inflammation. All this has been shown in studies.
Yep. Yeah. I published that in 2016. It was, using cross-polarized images of the face to look at erythema and inflammatory markers. There have been studies showing that it actually, I mentioned earlier that ultraviolet radiation, one of the chief ways that it causes damage is through creation of these reactive oxygen species. So there was a study done that showed if you're using this stuff, there is actually a higher dose of UV needed to damage your skin. So it actually raises your threshold for having sun damage, and it made the recovery from those damaged areas faster. this was providing like an internal sunscreen to people by reducing the reactive oxygen species produced by the ultraviolet radiation. And I mean, there are studies that looked at, cardiac health over 2 years and reversing plaque thickness. There was a fertility study done that showed improved rates of fertilization with in vitro. This stuff, it's like at a root cause level, it addresses all things related to reactive oxygen species, which really it's at the heart of inflammation and so many disease processes.
Yeah, it's one of the hallmarks of aging. This has been very insightful for me. So I'll definitely will put that out there, and I'm gonna try to get back on that. I know you'd given me some at some point, but this has really changed my thinking on it.
I love to hear that. I can't tell you how happy I am. Honestly, I tell people, look, if people who I really care about in my life, I make sure that they're on this stuff. It's hard to say. It sounds like snake oil. There's no such thing as a magic bullet, but if there was, this is as close to it as possible. I mean, it's plant-derived. It has no real side effects. It contains gluten, but it's a very small amount. It's only 30 milligrams, which is way less than the recommended daily limit for celiac patients, which is 50 milligrams. So it's something to be aware of, but it's an important part. I mean, it's a required part of the molecule. That's how it's protected. So, all that to say, it affects the root cause level of so many different disorders. I recommend it to anybody who's willing to listen to me.
Okay, awesome. What's your plan over the next 12 months? What are you working on now in the longevity space?
So about a year and a half ago, I helped to co-found a company called HealthSpan Digital. And HealthSpan Digital is a B2B company that curates longevity tools. And the intention is to give those tools to clinicians and practitioners in all areas, whether it's primary care or the aesthetic world. We're looking to empower clinicians and clinics to provide longevity services to their patients. And we have a full suite of AI software and physiology lab tools and supplements. And we've curated. I mean, we picked the best of the best and put it together. And so, yeah, healthspan.digital is our website, and our goal is to, empower the world to deliver longevity.
I think that's a whole other conversation. And your practice, is there anything else that you're changing?
Over the past few years, I have become more and more involved in my patients' health. I spend more time counseling my patients and discussing diet and exercise and ways of improving their health. So I have made that shift, and I'm now starting to apply these tools in my practice. So, I'm kind of using my practice as a petri dish to test out these tools. Epigenetic age markers. I'm now taking my patients' intake. When someone's having surgery, I use those biomarkers and the tests that we're doing to actually fuel an AI generator that can help me, teach the patients about lifestyle changes. I'm really working on creating a bridge between the aesthetic world and the health world. As you said earlier, beauty is not just skin deep. So, helping somebody achieve good beauty and helping them achieve it through good health. I mean, that's the right thing to do. I like to call that beauty span. The idea that someone's beauty is a longitudinal thing that is best maintained over time, and ideally through health means, not just at the end of a needle or a scalpel. So beauty span is that concept that we're trying to pioneer and grow, starting with my practice. And then, I have colleagues and a network of facilities that we're going to be launching that in. So I'm really excited. In the next year, we should have that off the ground. And I'll keep you posted.
Okay, thank you so much. I really appreciate your time today. And we're going to put those links in the show notes where they can get Glycin, the type of sunscreens, if there's any type of topical products you recommend. And then where can people contact you if they want to learn more?
Beautyspan.com is the sort of place where we're putting together our Beauty Span health initiatives. So that's probably the best place to find me. And if there are any businesses out there that are looking to grow a longevity, a platform within their existing infrastructure, we have the tools for you. And healthspan.digital would be the place to look for that.
All right. Thank you so much.
It's my pleasure. Thanks so much, Sanjeev. It's been a pleasure chatting with you.
Hi, everyone. It's Dr. Goyle here, and I hope you enjoyed today's talk with Dr. Cory Goldberg. Today, we learned a few things. One is everything about antioxidants and the importance for that in our health. We learned about a supplement called Glycin, which we can get on Amazon, which is very strong on removing antioxidants in our blood. We also learned about exosomes, and we learned about senescent cells. And then finally, the moniker that he gave us, that skin is health, I think rings really true. We don't normally think of it, but because the skin is the largest organ in the body, it is a very good reflector of our health. So I hope you enjoyed today's talk, and we'll see you next time. If you enjoyed today's podcast and you felt you learned something that can help you on your journey, please hit subscribe, like, and I'd love it if you'd share this with a friend who you think would also benefit and get inspired. And leave us a review. We're always looking for feedback on how to deliver more value to you. So take care. Until next time, I'm Dr. G from Peak Human Labs Podcast.